name is Karuna Singh. Welcome to the channel North Star Continuous Knowledge Excellence. In this video, we will get to know about the detection of food pathogens, gram-positive bacteria. Now, our expert, Professor Himadri B, Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Terry Tyson Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
This is detection of food pathogens, gram-positive bacteria. Okay, again we are going to make a nano platform, which is the working electrode will have a nanomaterial on its surface. In this particular case, it is going to be zinc oxide. The morphology of rod shape arrays on the zinc oxide. In addition to that, we are also going to have silver nanoparticles on it and very well-known antibacterial agent vancomycin there. Because the purpose of this study is not only detect, also eliminate the bacteria from the sample. That is what is the objective of this experiment. Silver nanoparticle has antibacterial activity. You are adding an antibacterial compound to it that will enhance that. And zinc oxide with silver will provide sufficient conductivity to the electrode and make the electron transfer from the electrolyte to the electrode much more efficient. Okay, so this is the entire package we have in our hand now, which is very useful. Now, this gram-negative bacteria that we are talking about, this is very predominantly present in food products, both processed food and stored food over a long period of time, particularly that contain a lot of protein in it. So detection of this bacteria is quite useful in preventing food poisoning, or the quality of testing the quality of the food. So this is the depiction of how the electrode really works. We'll go into details of this thing in subsequent slides. So we have the electrode surface. On that, we are going to have this zinc oxide rods here, okay, these things. And on that, we put this antimicrobial chemical, vancomycin there, which is attached here. And this gold and this zinc oxide rods that you see, we are going to have silver nanoparticles sitting on the zinc oxide rods. And the bacteria in this particular case is S. aureus, Streptococcus aureus here. And when it binds to this thing, it's not only the current changes because of the change in the electrochemical potential of the electrode, but when the bacteria comes in contact with this antibiotic compound and also silver nanoparticles, it undergoes death.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
And there is an elimination process, and the correspondingly there is a change in the concentration. Like here, again, we are looking the data from the impedance spectroscopy angle. Without the sample or without the bacteria, then you see its behavior like this, and after a while the changes to this one when there is an inactivation in the process. We'll see details of this thing in subsequent slides here. First is make, again, as usual, to design the electrode. Okay, so FTO is a fluorine doped tin oxide. It is available as glass slides. This is used as the electrode here. First, this is cleared in acetone to take out all the grease and all the oily materials from the surface, washed with sodium hydroxide with certain concentration, dry at room temperature, and then you allow zinc oxide nanoparticles to grow on these rods. And that process is described here. First, preheat the FTO electrode and then immerse in a particular concentration, 25 millimolar zinc nitrate, and hexamethylene tetraamine solution at 90 degree for a couple of hours. So you'll see the zinc rod nano structures will develop on it. Then it's basically rigging with molecule water and then drying it under moderate temperature, degrees Celsius or so for future use. So this is the fabrication of the electrode and making the zinc oxide rods on it. Array of rods, let us say. Next, you have to put the silver nanoparticles. So this FTO-ZNO electrode is now immersed because that is now the substrate that is immersed in zinc silver nitrate solution, which is the precursor for the silver nanoparticles, and then add certain amount of ascorbic acid. Concentration is written here, and let the reaction happen at room temperature for over an hour or so. Then silver nanoparticles will get formed, and they will all get deposited on the surface of the zinc oxide rods. After that, you incubate it in this antimicrobial solution, written as VAN here, a certain concentration for about 2 hours. Then you dry it in nitrogen, and now electrode is ready with all the prerequisites sitting on its surface. So you have the antimicrobial agent there, you have silver nanoparticles there, zinc oxide rod array is there, and the substrate is the fluorine doped tin oxide, FTO. So your working electrode is now ready for use.
I hope you liked the video. Here I would like to give you an important information that Nanoscience and Technology Consortium or NSTC organize the nanotechnology workshops on amazing topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. One more thing, and that is, if you want the full recording of the previous videos, so you can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshops, then you can go to the website www.nanoschool.in. And yes, subscribe to the channel Knowledge Star and hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.